Greetings and welcome to the CCOF Foundation Soil Health Webinar. We're very excited to have you here today. Our presenters from the Organic Farming Research Foundation will review findings from the recent publications on soil health and soil organic matter, as well as practical guidelines for organic growers to build healthy soils on their operations. Before we begin, I wanted to give a warm thank you to our sponsor, True Organic Products, Inc. True is a worldwide leader in diverse and innovative production of organic fertilizers, a family-owned business who respectfully treats their growers' land as if it were their own. True is passionately dedicated to manufacturing the highest quality, safest, easiest to handle organic fertilizers developed to help grow your business. If you're having difficulties connecting to the webinar, if you can't hear or if you can't see, please call our office for support at 831-423-2263. Press 0 for the operator, and someone will help you connect to the webinar. My name is Megan Donovan, and I will be your host today. I'm a program specialist at the CCOF Foundation. The CCOF Foundation advances organic agriculture for a healthy world through education and hardship grants, technical assistance, and consumer education. Before we begin, with our first speaker, I wanted to review a few housekeeping items. We are pleased to announce that this live webinar broadcast has been approved for Certified Crop Advisor Continuing Education Units. To receive credit for attending the webinar, include your full name and CCA certification number in the evaluation form at the end of the webinar. You must attend the entire webinar to receive credit. I also wanted to let you know how you can participate in today's web event. We're looking at an example of the GoToWebinar attendee interface, which is made up of two parts: the viewer window on the left, which allows you to see everything the presenter will share on their screen, and the control panel on the right. Within the control panel is how you can participate in today's event, so let's take a look at that. By clicking on the orange arrow, you can open and close your control panel. From the view menu, you can also set the control panel not to auto-hide when it's active if you prefer to keep it always open. The audio pane provides audio information. By default, you have joined the webinar by mic and speakers. If you prefer, you can join the audio via telephone by selecting phone call, and the dial-in information will be displayed. During the presentation, you can send questions to our webinar staff through the questions pane. Simply type in your question and click send. Throughout the webinar, we will stop from time to time for questions and comments. We will answer as many questions as we have time for. And as a final reminder, today's webinar is being recorded, and everyone will receive an email with a link to view the recording of today's event along with a PDF of the PowerPoint slides. So we'd like you to go ahead and test out the questions pane. If you could let us know where you're calling in from today and what you produce. And also, just to let you know, we have a lot of you in the audience today. Right now, there's about 150 people logged on, which is great. We're really excited that soil health is such a popular topic, and we will try to respond to as many questions and comments as possible. We wanted to apologize in advance if we aren't able to get to your specific question, and we'll provide resources at the end of the webinar for you to further explore the science and practical aspects of building healthy soils on organic operations. So thanks again for being here today. It's my pleasure to introduce today's speakers. Joanna will be giving the main presentation, and Mark Schonbeck will be online to answer questions. Joanna Ori believes organic agriculture is essential to protecting the environment and public health. Having researched the impacts of pesticides on human health and the environment for her doctorate in environmental studies at the University of California, Santa Cruz, she is excited to support organic farming and positive changes in the food system at the Organic Farming Research Foundation, also known as OFRF. Joanna is a passionate educator and teaches classes at UC Santa Cruz. She's excited to work with and learn from farmers and researchers at her work at OFRF. Mark Schonbeck has worked for decades as a researcher, consultant, and educator in sustainable and organic agriculture. He has participated in on-farm research on mulching, cover crops, minimal tillage, and nutrient management for organic vegetables. Mark helps edit the Virginia Association for Biological Farming, a quarterly newsletter, and serves as a policy advocacy liaison. He has collaborated with OFRF on a number of projects, including OFRF Soil Health and Organic Farming Educational Guides, which we're going to hear more about today. So Joanna and Mark, thank you for being here today, and we'll pass it over to you.
Wonderful, thank you. And welcome everyone to this webinar. This is Joanna Ori, and I am so pleased to present on our new soil health guide. It's called Soil Health and Organic Farming. And the one that I will be focusing on today is on building organic matter and how that relates to overall healthy soils. In this webinar, we're going to be focusing on a few different topics, trying to advance to the next slide. The first topic we'll be talking about is what are the needs in terms of soil health and what we've learned from farmers. We're also going to answer a few questions like what is healthy soil, what is the role of organic matter, and how can organic farmers increase organic matter? I'll be giving you practical tools, and I also would love to hear from you during our question and answer session about your challenges and also your ideas for increasing organic matter. We'll end the presentation by talking about resources and future research directions in soil health and organic farming. I want to give you a little bit of background on our organization, the Organic Farming Research Foundation, OFRF. Our core work is focused on research, education, and advocacy, and we aim to foster and improve the widespread adoption of organic farming through these three strategic areas. As part of our research area, we conduct original research about organic farming systems in the United States. And part of this is conducting surveys of organic farmers to learn about their most pressing needs and their experiences. Our latest survey was conducted in 2015, and we conducted this nationwide survey of U.S. organic farmers to find out about their most pressing challenges and research needs. We also wanted to give recommendations for ensuring that research funding is relevant and responsive to the actual challenges of organic farmers. And we used this survey to write a report called the 2016 National Organic Research Agenda. And this report is available on our website in full. And what it is an analysis of the survey findings and a look at the challenges that are facing today's organic farmers. What our survey found is that the highest priority among organic farmers in terms of new research and information was on the topic of soil health. 74% of survey participants rated soil health as a high research priority. They wanted to know about topics like defining soil health criteria, researching best practices for coping with climate variability and climate change. They wanted to have tools for rapid measurement of soil health and quality. And there was a lot of interest in investigating the relationship between soil quality and crop management practices. This is going to be a real focus of this webinar, is looking at what type of organic practices really benefit soil quality and overall crop health. And lastly, there was a need for researching the efficacy of different soil amendments for building soil fertility and enhancing yield. Overall, OFRF used this information from the survey, and we really recommend increasing soil health research as a major priority in the United States from the USDA and for private researchers, because we see soil health as the basis of agricultural productivity. In our survey, farmers had several comments about the types of information and challenges that they experienced. For example, one farmer wrote in, "I really would like to know how cover crops can be used to provide fertility requirements in perennial systems where tillage is not used." This was a very common type of question where farmers were interested in learning about how different cover crops and crop production techniques were going to really benefit their soil fertility. To answer these questions and to provide farmers with useful resources, we have produced a series of soil health guidebooks. These are available at our website, ofrf.org. And they cover topics such as weed management, tillage, cover cropping, compost, water management, as well as plant genetics and plant breeding, all related to the topic of soil health. And we really hope that these guidebooks will be an important resource for organic farmers in providing practical lessons that they've learned from research. In today's webinar, we're going to be focusing on this particular guidebook, Building Organic Matter for Healthy Soils, an overview. The research that went into the guidebook was based on findings from research projects funded through the USDA, OREI, and ORG programs. So this is research has been funded in different parts of the United States, and we've collected this information and tried to provide practical tools and lessons for farmers from these different research projects. We've also done additional scholarly literature review to supplement the USDA research, and we've done interviews with researchers to learn about their particular projects and what lessons farmers can take from them. I'll start with the real content of this webinar by talking about the question of what is healthy agricultural soil? So what are the characteristics? This is a nuanced question based on characteristics of each field and each farm and region. However, there are some commonalities. For example, it is very important to know your soil, especially if you have degraded soil or are transitioning to an organic system. And a healthy soil is going to have the characteristic of a sufficient but not excessive supply of plant nutrients. This will allow for optimum plant nutrition and good crop yields and quality. An important part of this is also that there will be no or minimal nutrient losses through leaching, runoff, or denitrification. This aspect is very important in terms of reducing the environmental consequences and impacts of nutrients in farming. The next characteristic of healthy agricultural soil is good structure and aggregation with a network of large, medium, and small pores. These pore spaces provide easy infiltration of rainfall and irrigation water. You can see this in the diagram. The diagram on the left shows good soil structure, with large pore spaces in which water and air can infiltrate, whereas the diagram on the right shows that the soil is compacted and there are very few pore spaces, small pore spaces. This means that water cannot infiltrate or be held as well. Good structure is a very important indicator of soil health, and this is very important especially in drought-prone areas like California, where good structure will allow for water infiltration and storage, as well as drainage and aeration. Good structure will also allow for deep root growth and the reduced need for tillage. Another characteristic of healthy agricultural soil has to do with the resistance to erosion, compaction, and nutrient losses and other forms of degradation. You can see in this diagram, again, good soil structure on the left with pore spaces, whereas the soil on the right is compacted. Healthy soils will have these pore spaces and aggregates that are not compressed, and they will also be free from soil crusts. This is very important, again, for the purpose of having water infiltrate and be stored. Another characteristic of healthy agricultural soil is resilience, ability to recover following an episode of degradation. Good soil health will be of particular importance to farmers who may be transitioning to organic production after a period of degradation. So building this kind of resilience into your soil will really help with the transition process. And following that, we have crop resistance or resilience to stress. This includes the reduced risk of yield loss during periods of environmental stresses like pests, pathogens, drought, heat, and cold. Healthy soil also requires fewer inputs because of efficient nutrient and water cycles and fewer pest problems. When we have fewer pest problems, it's going to mean that we have lower populations of weeds, plants, plant pathogens, and parasitic organisms. And an important part of healthy soil will be not only having few pest problems, but having large and abundant populations of beneficial organisms. In addition, healthy soil will have plentiful soil life and soil organic matter. Soil organic matter is the main topic of today's discussion. So I will now give a little background about soil organic matter in organic systems. So, soil organic matter is the part of the soil that consists of plant and animal materials. In most productive agricultural soils, you'll find between 3% and 6% organic matter. Organic matter and soil life play central roles in soil health and fertility. In natural plant communities, the daily consumption and assimilation of organic residues by soil organisms provides the primary source of plant nutrition. This is very important because in agriculture, we would like to mimic this kind of natural system where the plants are drawing from the soil and their organic residues and the support from the soil food web to give the proper nutrients. Without regular inputs of organic materials derived from photosynthesis and other life, soil organisms go hungry. So it's very important that we're supplying the soil with plant residues and nutrients in order to support agriculture. Soil organic matter is comprised of multiple components. These include plant and animal residues. These are recently incorporated into the soil by field operations or by earthworms and other macroorganisms. It includes the soil life itself, so living organisms. It includes active organic matter. This includes recently dead soil organisms, root exudates, and partially decomposed materials that remain available for further utilization by soil life. And it also includes stable organic matter, which is protected from further decomposition because it is physically integrated into soil aggregates, or it has become chemically resistant to further breakdown. So the question arises, how can we best increase organic matter? There are a few key practices, and I will go into more detail on some of these as the presentation continues, but generally, as a rule, it's good to return manure and crop residues to the soil, to compost materials to stabilize nutrients, and to develop humus before applying to the soil, to use organic mulches, to grow cover crops to let the residues return to the soil, and to diversify the crop rotation. It's also advisable, when possible, to integrate crop and livestock production. Now, I've gone over some of these practices that are useful in increasing soil organic matter, but we also have challenges in maybe putting these practices into place. And there are several challenges in organic systems that require careful management in order to build soil organic matter. I'm going to talk about a few of them, but I would also like to hear from you. What are your biggest challenges when it comes to managing soil health and building soil organic matter? I would really like it if you could write into the chat pane some of your own specific examples and challenges and experiences when it comes to managing soil health and building soil organic matter. And then I'll go over some of them in the next few minutes, but please, while I go through the next slides, it would be wonderful if you could contribute your ideas to that question. What are your biggest challenges when it comes to managing soil health and building soil organic matter? So one of the challenges that many organic farmers face is the challenge of managing tillage in a way that will not harm soil organic matter. Tillage and cultivation that are required for weed control can accelerate soil organic matter oxidation, or they can degrade the soil aggregates. Some practices that maximize soil organic matter and soil health, such as minimum till, sometimes entail yield trade-offs. So that can present organic farmers with difficult choices. Another challenge is that some crops require nitrogen more quickly than soil life can mineralize it. This means that concentrated organic nitrogen sources like poultry litter can enhance crop yields, but they also have the risk of leaching nitrogen or accelerating soil organic matter losses. Managing compost is another challenge in organic systems because frequent compost applications are very beneficial and can sustain yields in intensive production, but there is also the risk that they can start to accumulate excessive soil phosphorus or, in high tunnel situations, soluble salts. Another challenge in organic systems is that many of the modern crop cultivars have been bred for very input-intensive conventional production systems. And these cultivars may not perform optimally in organic systems with the particular soil health characteristics of organic production. And so they just have not been designed for optimal soil health conditions. So I'd like to go back to my question. What are your biggest challenges? And I'd like to take a couple minutes to hear about a few of the challenges from the audience.
All right. Thank you, Joanna. So some of the challenges that people mentioned are increased carbon costs, bugs, establishing crops and fields with intensive species, steep hillsides and avoiding erosion, and application rates. And then I just wanted to let you know too that we have people calling in from all across the United States, as well as we have people from Canada and Turkey. So we have a broad geographic range. And some of the things that people are producing are lettuce and herbs, carrots, apples, dairy products, bell peppers, sheep, beef cattle, and bell peppers. So wide range of different crops as well.
Wonderful. Well, it's really incredible that we have such a diverse and regionally diverse audience, and also the types of crops people are producing. And that also means that the types of challenges that farmers face are probably also going to be diverse. And yet we also have universal issues and challenges that all farmers face, and practices that can be applied so that we can farm in the most sustainable and efficient ways. I'd like to explore in the next part of this webinar what is known through research that can help meet some of these challenges. And I'll give a few different recommendations that we have for starting, for getting to know your soil and for dealing with soil organic matter. So the first thing that we recommend for all farmers is monitoring for soil health and soil organic matter. We're trying to advance the slide. It seems stuck.
If you try clicking on the screen, that should help. The image of the slide.
Okay, thank you. So for monitoring soil health, the first step is to get to know your soil, and we recommend using a soil survey to identify soil type, texture, and other inherent properties. And one such survey is available on the NRCS website. It's the NRCS Web Soil Survey. And getting this basic kind of soil type information is very useful, especially when you combine it with direct observation and soil test reports. And this provides an important starting point and baseline information for which to track future changes and responses to management practices that you as farmers might implement and experiment with. The second step of really getting to know your soil is to conduct annual assessments of soil health at the same time of year in successive seasons. And to do this, we recommend observing soil and crop conditions in each field, obtaining a standard soil test from a reputable lab that includes total soil organic matter analysis. We recommend to use a soil health scorecard for your region. They're specific to different regions to estimate overall soil condition and identify areas of concern. The next step would be to conduct quantitative field measurements of dynamic soil properties using simple protocols and a soil quality test kit. And then you might want to also obtain a comprehensive analysis, such as the Cornell assessment of soil health. So beyond these testing and these different monitoring tools that you can use, we also recommend observation. And we have several tips. These include looking for questions like, is the topsoil soft and crumbly with visible aggregates? That's what we want to see. Or is it hard, cloddy, or crusted, meaning that water can't infiltrate and the soil may be compacted? Is the topsoil a dark, rich brown, which would indicate high soil organic matter? Or is it a lighter tan or reddish color, indicating low soil organic matter? Is there a subsurface hard pan that could restrict root penetration Does rainfall or irrigation water soak in quickly, or does it tend to pond or run off? We'd also recommend looking to see if crops are thriving and resilient, or if they suffer from environmental stresses like drought and disease. We also recommend digging up some plants. Are the roots deep, abundantly branched, and a healthy white color? That's what we would like to see. Or it might be an indication of poor soil health if the root growth is restricted or affected by disease. Another tool that farmers can use to observe soil health is whether or not there are earthworms present and other macroscopic, so insects or other organisms that you can see with your eye, these soil organisms, if they are abundant. And when you dig in the soil, you want to see numerous worm casts and burrows. And a good indication of soil health is having several worms per shovelful that indicates a healthy food web in the soil. There are other management practices that are considered best practices. These are put forth by the NRCS, and they're considered management practices for soil health. So these are general practices that will help to maintain soil organic matter and soil health overall. This includes to keep the soil covered as much as possible, to grow living roots throughout the year, to use diversity of plants to enhance soil microbial diversity, and to manage more by disturbing soil less. The central theme here is that living plants are the farmer's primary soil health management tool. Cover crops play a pivotal role in managing the health of crops and soils. And if you implement these 4 key principles, it's a really good baseline for creating healthy soils and good soil organic matter content. I'm going to go into a few different practices and research findings on each to give some more specific information. So I just mentioned that cover cropping is very important to keeping the soil surface covered as much as possible. This is really important because inadequate plant cover and inadequate root biomass can cause a decline in soil organic matter levels. This is regardless of the type of tillage. Not having enough plant cover will reduce soil organic matter levels. And one example of this is a research study done in 2015 by researchers Hu et al., Hu and others. And what they found was that winter annual legume cover crops, this includes hairy vetch, crimson clover, and Australian winter pea, comprise 70% of the total below ground biomass. So it's a really important form of biomass in the soil system, and that the fine roots of these cover crops became the readily available microbial food for the whole soil system. And this increased the microbial biomass and soil organic matter in the system. So if we want to really use cover crops to increase soil organic matter, there are a few steps to take. This includes using high biomass, multi-species cover crops in annual crop rotations, using cover crops and compost together in your cropping system to rebuild and maintain soil health and fertility, to apply manure at the same time as cover crop planting if it's warranted by a soil test. So using monitoring to guide that practice, but knowing that it is a good time to apply manure if warranted. And then adding cover crops to an intensive cover cropping system will allow you to reduce the amount of compost. Certain cover crops may be especially well adapted to certain soil fertility or moisture constraints. For example, the following cover crops, sun hemp, pearl millet, cowpea, and buckwheat tolerate and also help remedy low soil fertility. Another example is that if soil nitrogen is low, legumes are often a good choice in terms of having them in your cover crop mix. The next practice I'll talk about is compost. And inputs such as compost, manure, and organic mulching materials play a supplementary role and can enhance soil health outcomes of crop rotation and cover cropping. I'll mention that these practices don't stand alone. They work together to really enhance soil health and enhance soil organic matter. What compost does is it adds both active and stable soil organic matter, as well as a diversity of beneficial organisms to the soil. One thing to keep note of is, though, that relying on compost alone to maintain soil organic matter can have problems such as nutrient excesses, especially of phosphorus and salt. But overall, compost can have long-term benefits for soil organic matter. One research study from 2015 performed by Reeve and Creech on dryland organic wheat production in Utah found that a single application of a dairy manure straw bedding compost at 22 tons per acre in 1995, so this one application, more than doubled total soil organic matter measured 13 years later. So this is evidence that compost applications can have real long-term benefits for overall soil organic matter and health. So here are a few guidelines for using compost. Use compost, manure, and other amendments and microbial inoculants to complement crop rotation and cover crops. Adjust amendment rates according to soil nutrient status, so using monitoring to know what type of amendments to use. And then feed the soil a diverse mix of high and low C to N inputs. So balance nutrient-rich inputs like poultry litter or legume green manures with carbon sources like straw or rye cover crops. The next topic that is very important to managing soil organic matter is crop diversity and rotation. And this also is very important. It's connected to cover cropping and compost application. But what we've found in the research is that lengthening the rotation, so the crop rotation cycle, can really benefit soil organic matter. We found in certain studies that lengthening the rotation to include 1 or more years of alfalfa crops or other perennials can have real benefits in terms of soil organic matter as well as weed control. One research project performed at UC Santa Cruz by Carol Shannon and Joji Muramoto in 2015 and 2016 found that a 4-year rotation of 3 years of vegetables and 1 year of strawberry, so a longer rotation compared to a 2-year rotation of strawberry and broccoli, had much higher carbon sequestration and soil organic matter rates. This was the impact of a longer rotation with cover crops that really allowed for the soil to have more soil organic matter. So we have a couple of recommendations when it comes to crop rotation. One is to develop a diverse crop rotation that maintains soil coverage and living root biomass and provides sufficient organic residues to feed soil life and maintain soil organic matter. One way to do this could also be to integrate a sod phase in the rotation where practical, and to integrate crop and livestock production if possible. For example, when land resources and cropping schedules permit, consider a perennial sod break in the rotation to enhance soil health and fertility and to reduce weed populations. One other aspect of crop rotations and cover crops is that researchers and farmers have observed what's known as rotation effects, in which certain cover crops can enhance the performance of certain production crops planted after the cover crop. I'll give you a couple of examples. For example, soybeans planted after winter rye were seen to have much higher yields. Spring spinach thrives after fall tillage or after oilseed radish. And corn thrives after alfalfa or red clover sod, often needing no additional nitrogen. One last example is that hairy vetch or rye and vetch cover crops have been reported to enhance tomato crops. The next practice I'll talk about is tillage. And both active and stable soil organic matter play important roles in soil function. And a deficit in either type of soil organic matter can indicate a need for better management. Although excessive tillage degrades soil, sound organic management systems that include judicious routine tillage can still build soil organic matter and improve soil health. And there are different ways that we recommend to manage tillage, and this includes having an integrated organic weed management practice, which can reduce the need for tillage and cultivation in organic crop rotations. So when implementing tillage, we recommend tilling with care, so reduce tillage when practical, to implement an integrated weed management strategy that reduces the need for cultivation, to run a rototiller at a slower rate, combined with faster forward speed to minimize the destruction of soil aggregates, and to consider shallow conservation tillage that leaves some residue on the surface and leaves soil structure and root residues intact deeper in the soil profile. This is, again, building off of that NRCS principle of making sure that the soil surface is covered as much as possible. One other item would be to choose locally adapted crop cultivars that have been developed for and are well suited for organic systems, especially for weed tolerance, so that tillage might be reduced. The next item I want to talk about is water management. And this may be of particular interest to those of you who are located in California or other drought-prone areas. And enhancing soil organic matter is very important for increasing the soil's ability to hold moisture, even in times of water scarcity and drought. And we have a couple of recommendations for how you can do this. One would be to include a deep-rooted and perennial crop in the rotation to build soil organic matter, to increase biological activity, and to really make sure that your soil structure includes these deep pore spaces and the water is able to infiltrate, and that the plants have access to this deep moisture. Another tip is to apply soil amendments, including manure, crop residues, straw, hay, silage, and compost that are going to really support biological processes that maintain porosity and moisture holding capacity. Adding these soil amendments will also increase soil organic matter and overall holding capacity in the soil. To wrap up this webinar, I'm going to talk about future research needs. So these have to do with some of the challenges that you've expressed in the survey and also today when you wrote in your responses. And we'd really like to see more research on reliable and practical measurement protocols for soil organic matter so that farmers can use it to track soil health trends and impacts of management practices. We also think that it's important to have more research on practical guidelines regarding optimum or target soil organic matter levels, and to continue to develop practical, reliable, and affordable field or lab methods for measuring soil health parameters related to tilled fertility and the soil food web function. It's important to develop, test, and refine soil health assessment protocols and also to do more research. I've presented a bit on cover crops and other types of amendments, but it's a real farmer challenge to know what type of amendments are best suited for their farms, and we'd really like to see more research into determining the impact of different amendments on microbial activity and soil organic matter. And lastly, we'd also like to see more research on the role of living root biomass in maintaining active and total soil organic matter, as well as having practical guidelines in designing crop rotations and cropping systems that really maximize root biomass. I really appreciate your time and attention, and I know that there's a lot of information, and so I want to provide you with additional resources for you to do some of your own reading, and all of the soil health guides on the different topics are available at the OFRF website, ofrf.org. In addition, OFRF funds research projects, and we have a research database with more than 300 projects that are available for you to research and to learn about the research findings. They are all free final reports available for you to download. And we are currently making grants, and our next application period will open in September. So if you'd like to learn about that or any of our upcoming education and grant making opportunities, you can sign up for the monthly newsletter at our website. Lastly, I would like to thank our sponsor of these guides. It's the Clarence E. Heller Charitable Foundation, and their generous support made it possible for us to do the research, writing, and publication of these soil health guides, which we hope will be valuable resources for organic farmers in really promoting soil health and healthy environments. So this concludes the presentation portion, and we will be having a bit more conversation and question and answer right away.
Great, thank you, Joanna. That was a really nice overview of what soil health is, and as well as a lot of practical applications that growers can use for building soil health on their operations. We've had a good number of questions come in, and Mark, I also just wanted to invite you to jump in to answer questions as well.
Yeah, I'm now connected, unmuted.
Okay, great. So the first one is just sort of a clarifying question. Joanna, someone was wondering if you could explain what you mean by sod phase.
Oh, yeah, that's pretty easy. A sod phase is just when you put a field into grass and clover. It's perennial for several years, 2 years or more usually.
Great, thank you very much. And then could you talk about soil health in perennial crops, so orchards or vineyards, that type of thing?
A lot of these systems are managed with bare soil or very minimal soil cover. And not only does that get very dusty, but it's very hard on the soil quality, and it's going to be hard on the trees. And it'll work much better. Once the crop is established, you can let an understory of grass and clovers grow. And this will depend, of course, on the rainfall of your region, how soon you can do this and how close you want to let it get to the base of the trees and such. But basically, in a perennial production crop, especially one that's wide-spaced like orchard trees or vineyards or cane fruit or the 10-foot alleys, blueberries, such like that, at the very least, you want the alleys covered with perennial cover. That's mowed a few times of the year. That also provides better trafficability, but essentially you're maintaining soil quality, and you can regulate the competition with the trees or vines based on rainfall and your needs. You could use organic mulches if you really don't want anything growing there at all, or you can grow an annual cover crop during the part of the year when rainfall is abundant, and then mow it off and let it just lie as a dead mulch. There's various other, during the dry season, there are various ways to manage that area closer to the crop. But the idea is to again, just keep the soil covered. And when you have a perennial crop, you have the advantage of much less tillage to begin with.
Great, thank you. Another question also came in as to asking when it's best to apply practices to increase soil organic matter. Is there, a better time of year, that type of thing?
Basically year-round. Main things are to choose crops when you're planting cover crops or perennial sod for soil health. You want to choose the ones that are going to thrive in the season when you're planting. And then, of course, you want to avoid tilling the soil when it's too wet or too dry. Those are the main seasonal considerations.
Okay, great.
And perhaps also avoid applying nutrient-rich organic materials when you're going into the winter, like on snow or frozen ground. You'd want to spread manure then. You want to plant it when you're got an actively growing cover crop or something like that.
Great, thanks. And then we had another question come in asking about the measurement of soil microbial populations by measuring soil respiration. Kind of what your thoughts are on that, or how that works.
That is an area that I need to look at a little more closely. That is a common measure, soil respiration. The interpretation could be a little tricky. You could have a spike in soil respiration after feeding the soil something that is too rich in nitrogen, like a lot of poultry litter without a lot of carbon. It can cause a burst of respiration, which actually burns up organic matter. Or high soil respiration, on the other hand, could mean that the soil is indeed very alive. You have a lot of biological activity. You've been feeding it a good mixture of materials. Or it could reflect a burst of activity resulting from tillage, and then you're releasing nutrients, but you're also burning up organic matter. There are certain situations where, in spring, the soil is kind of cool. You want to go ahead and till a little bit to get the soil life wakened up so it's releasing nutrients, but being aware that you are expending some of the soil's capital, the organic matter. So interpretation of that respiration number can be really tricky, and I believe there are a number of teams researching that and refining that interpretation.
All right, thanks. And I think another question that came in is recommendations on mulches and the pros and cons of using mulch.
Oh, that's a complicated question, a little bit complicated, but usually the benefits outweigh the drawbacks. Things you want to watch for in organic mulch is that it can bear weed seeds, and sometimes in the case of hay or straw or something that's been taken from a non-organic field, especially, there may be residues of highly persistent herbicides, which not only could affect your certification status for up to 3 years, but it could also severely damage your crops. These are the pyridine carboxylic acids, the picloram, the aminopyrrolid, clopyrrolid, and something else called aminocyclopyrrochlor. These are all highly persistent. Also the weed seeds, and there are situations where you're having a very wet season. The mulch can harbor a lot of slugs. There are certain pests that increase under mulch. There are many advantages. If your season is average to dry, it's conserving soil moisture. And just by keeping the soil covered with even a dead mulch, if you're not in a situation where you want living vegetation growing between your crop rows, but you want the soil protected, like in a horticultural crop like tomatoes or something like that, it's really very beneficial in most seasons and in most climates to have that mulch there. The organic mulch lets the rainfall in, and then it very greatly slows evaporation losses, keeps the soil cooler. So it can actually conserve organic matter both by adding it and by preventing excessive heating and drying and wetting, intense drying of the soil.
Great, thank you. That's good information. And I just wanted to say we have a whole lot of questions coming in, and just acknowledge the fact that we're probably not going to be able to get to all of them. But again, we are very excited that this is such a popular topic, and it's something that we're going to think about in the future. We had a couple of questions come in kind of related to arid soils and soil management practices that enhance water retention in soil during the dry season, as well as improving soil organic matter in arid, coarse textured soils.
Those are actually challenging topics, and living in a humid climate with loamy soil, I don't have as much direct experience with that. I know this has been an area of interest and of some research attention in the Organic Research and Extension Initiative projects. Particularly critical, again, all I can say is the more open the soil profile, the more organic matter that it is added. Probably undisturbed living roots in the profile have a very beneficial long-term effect, although you do have to also consider the short-term immediate consumption of water by living plants. There may be circumstances where a non-living but organic surface mulch, like a dead cover crop, one that's been killed either by frost or by summer heat, or an applied mulch for a horticultural crop, something like straw or hay, making sure it's clean. Those materials will tend to conserve moisture and allow moisture to soak in, but will not be consuming it the way a living cover crop would. That's a really good question. And you also, coarse textured soil, you can actually have excessive drainage. So building the organic matter content of those coarse soils, for example, that addition of compost in Utah, that was a study you mentioned earlier. That's a very arid soil there. And it had a long-lasting effect both on yields and on soil quality. So that's something to keep in mind.
Great, thank you. We also had someone write in saying that David Johnson from New Mexico State would be a good person to look into for arid soils.
Thank you.
Yeah, and so Joanna mentioned this in her presentation, but how does shallow rototilling affect soil health, and how can it be avoided?
Rototilling?
Yeah, how does shallow rototilling affect soil health?
Oh, well, it will pulverize the surface, and if you set the forward speed and the rotary speed such that it reduces that pulverizing. Also, the better soil health to begin with, the less it will be, less quickly it'll be degraded by tillage and other disturbances. If you're going shallow, you will tend to pulverize that top inch or so, but you will leave the deeper layers intact. The best way to avoid it is just to do it when it's really necessary. Like if you're doing it for weed control, instead of cultivating, say, 3 times during a crop, you might cultivate once and then put a mulch down. Or you might cultivate once or twice, and then on the last pass, intersow a cover crop that will be planted enough after the main crop so that it's not competing. And otherwise, just look at other alternatives to the rototiller. I mean, there's rotary harrows, which are a little gentler. If you're cultivating, you could do knives or finger weeders and such, which kind of disturb the soil enough to knock out the little weeds, but are not pulverizing it as much.
Great, thank you. And we also had a question come in regarding molasses, and that there are different opinions on the addition of molasses and products containing molasses to the soil. Some say that the sugars cause blooms of microbes which are short-lived and not necessarily, and others that say they're not necessarily the microbes that are desired. So kind of what's your opinion on adding these additives to soil?
That's one of the soil health guides that didn't get written. We have yet to really dive in deep in the details of soil microbiology. Molasses is probably a bacterial food, because it is sweet, but it also is rich in various macro and micronutrients. Like molasses is better for us than plain sugar, so it's probably better for the soil than plain sugar. But the question as to whether it's going to help the right organisms or the wrong ones or just less effective ones, or that's going to have only a short-term effect, that will depend so much on what is currently in your soil and what you're growing. There are certain plant families that prefer a more bacterial soil, those being the brassica family, crucifer family, and the beet spinach family, or echinopods. And there's some other crops, individual crops that like a fairly bacterial dominated soil. And I would say on the balance, they're likely to benefit more from the type of microbial activity that the molasses will stimulate. If you want a more balanced bacterial fungal ratio, which would be most of the vegetables and grains and legumes, or if you want a fungally dominated for most of your perennial crops, for the balance, you might do a little bit of molasses and a little bit of some kind of seaweed extract, because the seaweed extract more favors the fungal component. And both with these fungal microbial food additives and the microbes themselves, whether or not it benefits the system is going to depend a lot on whether that particular group of organisms or function is already present and doing well, or if it is lacking or dormant. So, and most of the time, you will either get a benefit or no effect. You're not going to harm your soil very often with a lot of these products.
Great, thank you very much. So I think that's all we have time for today. Again, thank you everybody who attended and submitted your questions. We apologize if we couldn't get to them. But again, this is definitely a topic that's of interest to many people, so that's good to know. And Joanna and Mark, thank you very much for taking time out of your busy schedules to be with us here today and giving such a great overview of soil health and soil organic matter and all of the nitty-gritty on soil management and organic systems. We wanted to give you a couple other additional resources. Joanna gave a nice overview of where you can find out more about OFRF's research and grant making activities. We wanted to pass along some additional resources for technical and financial assistance for growers who are looking to improve your soil, and many of you may already be aware of them. But the USDA Natural Resources Conservation Service provides grants and technical assistance for soil conservation, including practices like cover cropping. At a county level, resource conservation districts may be a good resource as well. And the National Center for Appropriate Technology is a great resource for organic growers, and they have a 1-800 hotline that you can call with sustainable agriculture questions. So if they don't have the answer for you, they'll look it up as well. Farmers and ranchers in California can take advantage of the California Department of Food and Agriculture's Healthy Soils Grant Program that provides funding to farmers and ranchers who use on-farm practices that store carbon in their soil, trees, and shrubs. Some of the practices we talked about today, including cover cropping and mulching, are included in the program. If you're interested in applying for a grant, we can help you fill out your application, so contact us. The deadline to submit applications is September 19th. And check out CCOF's education page for upcoming events. This fall, we have webinars on food safety and cannabis regulations, as well as a webinar in Spanish on labeling and post-harvest handling for organic produce growers in Mexico. CCOF is one of many organic certifiers. In the United States, there are nearly 50 certifiers authorized to certify farms and businesses to the USDA organic regulations. So we encourage you to do your homework, find the certifier that's the best fit for you. The Agricultural Marketing Service website is a great place to check out all the different certifiers and see what options there are. If you're interested in learning more about certification at CCOF, contact our new applicant liaison, Jane Wade. She is more than happy to answer any questions you may have, and she has a great breadth of knowledge, so feel free to give her a call. Thank you. We hope you found this presentation helpful. Please fill out your evaluation form, and those wishing to receive Certified Crop Advisor Continuing Education units, please include your name and CCA certification number in the evaluation. And if you have any questions, feel free to contact me. We're always happy to talk with you or connect you to someone else. So thanks, and have a great afternoon.
Thank you.